So this is the last topic that we need to cover in this section of Unit 4. It is on functional groups in organic molecules. And like you can see there, the functional groups are really the reactive part of molecules. You don't get a whole lot of reactions from the hydrocarbon part. The single bonds between the carbons or the carbons and the hydrogens are pretty unreactive. You can get a little bit of reactivity at a double bond or a triple bond, but the reactions are really rather limited. So even though they're considered a functional group, there's not a whole lot of things we can do with it. So let's take a look at these different kinds of functional groups. Overall, a functional group is, like we said, the part of the organic molecule that's very reactive. It has a structure that is unique for that functional group. It undergoes very different properties. It undergoes very different types of reactions. And so chemists can really use functional groups to try and make new molecules because they can predict what kind of reaction will take place at that site. Most of the functional groups you're going to see involve oxygens, but there's a few others. You can have functional groups with nitrogens or halogens or phosphorus or other atoms. And like I said, when chemists want to create a new structure, they choose a compound with functional groups so that it will do what they want. So they take smaller molecules with functional groups and react them together to create new and different molecules. So let's take a look at a typical functional group. You're going to see it written like this: R, and then the functional group in this case is OH. The R actually stands for the rest of the molecule, but the OH is the part that we're concerned about. So like I said, literally R stands for the rest of the molecule. So we're really only showing you the important part when you see the formula for a functional group. So for example, for example, alcohols have an OH. So here you can see there are different types of alcohols. Ethanol is the alcohol that is in alcoholic beverages typically. Propanol is what is in your medicine cabinet when you want to disinfect something. So you can see that the one thing they all have in common is the fact that you have an OH on the end. The carbon and the hydrogen chain represents the rest of the molecule. So let's take a deeper look into these alcohols. Like I said, the functional group is an OH. It is called a hydroxyl group. Now, don't confuse it with the ion hydroxide. That is in an ionic compound. A hydroxyl group is in a molecular compound, an organic molecule. So it is an OH, but it's going to do something a little bit different than what happens in hydroxide. Alcohols, because there's only one bond needed to connect the hydroxyl group, can show up anywhere in the molecule. So it can be on the end, it can be in the middle. We call this, if it's on the end, we call it a primary alcohol. If it's in the middle of a chain, we call it a secondary alcohol. And if it's in a more complicated, attached to a more complicated carbon, you can actually get a tertiary alcohol as well. So alcohols are one of the molecules that you have to be able to name. And so really what we're going to do is we're going to take the name of the hydrocarbon and simply add an OL ending onto it. And then you will also see a prefix with a number attached to it, and that'll let you know what carbon the hydroxyl group is actually bonded to. So for example, here we have 1-butanol, because the OH is on the first carbon. 2-butanol has the OH on the second carbon. And then learning your branching schemes, if you've done that already, we've got the methyl, but then we also have an OH, so we have to call it 2-methyl-1-propanol. And then here is 2-methyl-2-propanol because the OH is off the second carbon as opposed to the first carbon. Okay, second functional group is called a ketone. So you can see there it is. That's a C double bonded to an oxygen. And so it is called a carbonyl group. And like I said, it consists of a carbon. The carbon can't be at the end of the chain. It's got to be within the chain. So both of these R's have to be carbon, at least one carbon. But it's a double bonded oxygen. To name the ketone, and again, the ketone is one of the other substances that you have to name. Instead of an OL, it gets an ONE on the end. And once again, a number as a prefix to let you know which carbon has the double bond. So here's some examples of various ketones. So here's propanone. We don't have to give a number to this one because the only place that carbon can be is on the second carbon. So propanone puts the carbonyl group on the second carbon. Same thing, butanone doesn't need, there's only one possible butanone. But then here you have a few others. 3-methyl, 2-pentanone, 1, 2, 3, 4, 5. Ketone on the second carbon, methyl group on the third carbon, and here's some diones that you can see. So ONE is the ending, and then a number to let you know where that is. Third molecule that you have to, or the third functional group that you have to know how to name is called an aldehyde. This is going to look really familiar to a ketone, right? Carbon double bonded oxygen, but notice what's different. Aldehydes are on the end. So the functional group is called a terminal carbonyl group, or sometimes they'll call it an aldehyde group or a formal group. But it really is a ketone on the end. So that carbon has a hydrogen attached to it instead of another carbon. So aldehydes receive the suffix al, and there's no need for a number because aldehydes always have to be on the end of the carbon. So you see something like butanal here on the right-hand side, 1, 2, 3, 4 carbons in the chain, and the aldehyde on the end. Here you've got 1, 2, 3, 4 carbons in a chain, but you got 2 methyls. So 2,2-dimethyl butanal. Again, the al lets you know that there's an aldehyde. Fourth molecule that you have to know how to name. There's 5 total that I'm asking you to be able to name. 4 of them have oxygens. Carboxylic acids are the last one. So carboxylic acids have this kind of structure. So it's got not just a double bonded oxygen, but it also has an OH. This functional group is called a carboxyl. It combines the carbonyl and the hydroxyl together. So that's carboxylic acids get their name from that carboxyl group because this OH actually winds up being acidic. The hydrogen will be lost. So it consists of, like what we saw, a carbon double bonded to an oxygen, but also singly bonded to an OH. Again, these guys have to be on the end. All right, what's going on here? Carboxylic acids receive the suffix oic acid. Oh, okay, that's what's going on there. And so you can see we've got butanoic acid, 1, 2, 3, 4 carbons with the carboxylic acid on the end. Propanoic acid, 1, 2, 3. 2-methyl pentanoic acid, 5 carbons in a row with a methyl group on the second, and so on and so forth. 3-chloro, you're going to learn how to name halogen-containing molecules shortly. Now, ethers are the first molecule that you don't actually have to know how to name ethers. They're a little complicated. You just need to recognize an ether is an oxygen within a carbon chain. So the functional group is called an ether. Again, oxygen within a carbon chain. Some examples we've got right here, methyl, ethyl, ether. So you can kind of see the naming schemes. Diphenyl, you haven't learned what a phenyl is yet, but you will. But you don't have to know how to name these. You just have to recognize that the oxygen within a chain is called an ether. Esters look alike like carboxylic acids, except they're in the middle of the chain. So carboxylic acids are at the end, esters are in the middle. So the functional group is a combination of a carbonyl group and an ether, or you can think of it as a kind of like a carboxyl group in the middle of the chain. Again, in the middle of the chain, you get 2 carbons on the outsides. Once again, you don't have to know how to name them, you just have to know how to recognize them. So here are 2 examples. You've got the C double bonded O within the chain, and then the double bonded O sticking above it. So make sure you look very carefully. If there's an extra O, it's not a ketone, it is an ester. All right, that should take care of all the oxygen-containing functional groups. I'm going to quit here on this part of the tape. We'll go to part 2 and take a look at functional groups with things other than oxygens.